Mercury orbits the innermost solar system, the closest planet to the Sun. Around 3 times closer than Earth. In a scorching environment of lethal heat and radiation. Capturing images was a monumental challenge for the Messenger mission team, led by Sean Solomon.
Mercury has been among the most difficult planets in the solar system to study. The Hubble Space Telescope is forbidden from viewing planet Mercury because it's too close to the Sun and their optics would be severely damaged.
Messenger looks closer than we ever have before. It reveals a strange world, just 5% the mass of the Earth. Closer in size to our moon.
At first glance, Mercury and Earth, they're nothing alike, right? They're both made of rocks. That's about it. They're both orbiting the same sun. But when you start looking a little bit closer at Mercury, you start seeing some really surprising similarities to Earth.
When scientists look at Mercury, they spot something that shouldn't be there.
Mercury has water on it, which if you were to make a long list of all the discoveries about Mercury, I think water would be right at the top of what? What? Seriously?
If you thought in advance of the last place in the world to find water, you'd think of Mercury because it's so close to the Sun.
It gets even stranger. The water exists in the form of ice. There could even be 1 trillion tons of it, enough to encase Washington, D.C. in a frozen block 2 miles thick. So how do you get frozen water onto the closest planet to the Sun?
Mercury's axis doesn't tilt very much compared to the Sun. The Earth's axis tilts about 23 degrees, but Mercury is pretty much straight up and down. And that means that as large as the Sun is in the sky, there are craters on the poles that sunlight never gets to. They're always cold. So the surface of Mercury is heated and then cooled as it moves around the Sun, but there are craters that are always dark and always cold.
Against all the odds, despite everything that suggests this shouldn't happen, Mercury is a safe haven for this water ice.
The bottoms of these craters are called cold traps because they're so cold that any water that gets there stays there basically forever, can last literally for billions of years. But where would it have come from? It probably came from comets and asteroids. Comets are giant chunks of ice. So if a comet hits Mercury, that's going to deliver a lot of ice. And in fact, we know a lot of asteroids have ice on them as well. So both of these things could deliver water to Mercury.
Comets and asteroids brought water ice to the innermost planets of the solar system. This same water delivery system gave Earth the elements needed for life. And though Mercury has pockets of frozen water, the planet can never use it to develop living organisms. We have theories for how the planets first formed in our solar system. But Mercury just doesn't fit in.
When you look at the family of planets that make up our solar system, Mercury does seem to be a little bit of a weirdo.
On Earth, we have a relatively small core and a thick mantle and a thin crust. So you compare the core of the Earth to the size of the Earth, it's relatively small. If you look at Mercury, it's not that way at all. The core is absolutely huge compared to the planet itself.
Mercury's huge iron core is surrounded by an unusually thin mantle of rock. It just looks odd.
It's funny, you don't expect to get a core that large in a planet that small.
It's almost as if Mercury lost some of its mantle somewhere. I mean, maybe it left it behind the couch. Who knows? But it's gone now.
But how can this material just vanish?
Mercury could be the way it is now because it started as a much larger planet and then something happened to strip away the top layer of it. And the only way we know how to do that on a planetary scale is with planetary impacts.
Picture the early solar system, when Mercury is still forming. It's completely different from the little world we know now. Up to 4 times more massive, twice the mass of Mars. But it orbits in a shooting gallery. Impacts are inevitable. And before long, an object the size of our moon smashes into Mercury in a giant impact event.
This is apocalyptic. This is the sweatiest nightmare you can have. You're resurfacing an entire planet. The energies are vast. One of these giant impacts probably would have remelted it all the way through. What's going to remain after it's done is completely different than what started in the first place.
For years, we assumed that Mercury lost most of its mantle in a giant head-on collision. But the Messenger spacecraft turned everything on its head.
One of the exciting things that we've learned about Mercury recently by sending probes to study its surface is that its surface is littered with material that we didn't think should be there, things that we'd call volatiles.
The volatiles are chemical elements like potassium. They're called volatile because they evaporate easily in high temperatures. Just the sorts of temperatures generated by a giant impact.
If I had to describe Mercury in a word, it would be surprising. The idea was that a smaller object ran into Mercury and knocked off material. Well, that actually would work to make it lose material, but it would also generate a lot of heat. And because of that, the volatile materials on Mercury would also have been lost. But today we see that they're still there.
So it meant that most of the basic scenarios that had been laid out for how Mercury was assembled had been disproven. We had to go back to the drawing board and rethink how Mercury was assembled and how Mercury evolved.
How did Mercury lose its mantle but retain these volatiles?
Mercury is like a detective case. We have the body, we have some clues, but we really have to piece it together.
Planetary scientist Eric Asborg tackles this giant riddle.
The original idea was that Mercury was hit by something smaller than itself. But whatever process made Mercury somehow preserved all these volatiles that should have vaporized and gone.
Eric has a bold alternative: a hit-and-run collision.
In the hit-and-run collision idea, you actually have Mercury hitting something bigger than itself without losing all of its volatiles.
Hitting something bigger may sound even worse, but it all depends on how you hit it. A head-on impact would send a shock wave across Mercury, melting the entire surface. But a glancing blow is less ferocious.
The more grazing you hit something, the less energy you bring to bear, the less violent it is.
A grazing collision is where a piece of the surface is grazed off and blasted into space, and the other hemisphere of the body is largely unaffected and allowed some primordial material to remain on the surface.
Most of Mercury's mantle is stripped away. But this grazing impact doesn't send a shock wave through the planet. And so, the volatiles remain, along with enough of the mantle to reshape this world with a thin outer layer of rock. Mercury was transformed into the smallest planet in the solar system. And its lost mantle was stolen by an unexpected thief.
That mantle accretes onto the biggest object around, but the biggest object around isn't Mercury.
When Mercury's mantle got knocked off in this collision, it had to go somewhere. So if you're looking for Mercury's missing mantle, look no further than right under your feet.
To this day, part of Mercury could be part of Earth. Stolen in a hit-and-run collision.
Mercury was able to survive the formation of the solar system, but it paid a cost. It was battered.
Since day one, Mercury has had a tough ride. it's been pounded by the sun and planets. And things have not improved since.
You can see by the surface of Mercury that it has a lot of battle scars. The solar system did not treat it well.
The planet has been bombarded and fried. Billions of years ago, Earth could well have collided with the young Mercury, changing Mercury forever. And now, it comes face to face with Earth once again, smashing into our planet in one final impact, wiping out any trace of the world we know and love.
It would melt our entire crust. It would wipe out all life on our planet.
So, how worried should we be about this threat?
The odds of this happening aren't that high. And if it happens, it's going to happen billions of years in the future. So I'm not terribly worried about it on a personal scale. But as an astronomer and as a scientist, that's fascinating.
Mercury may continue to surprise us, even to its dying day. A world born in fire that might also go down in flames. Earth and Venus may seem like very different worlds, but they shouldn't. They're roughly the same size, same mass, and made from the same stuff. And they started out as twins.
Early Venus and early Earth were very similar. They were twins, probably nearly identical twins at their earliest stages.
Given that Venus is so Earth-like in so many ways, it's really odd that it is so different than the Earth, and this makes it one of the biggest mysteries in the solar system. Somewhere in their two histories, the Earth and Venus took two very different paths.
The result? Two totally different worlds.
Their paths were so different, you could hardly believe that one would have been related to the other. But now the opposite thing's going to happen. We're going to catch up with our twin. We're going to evolve to be a lot more like Venus in the future.
In the future, the two planets' paths will converge, and they will become twin-like once again. There is going to be hell on Earth. The oceans will vaporize. The land will melt. Our hospitable blue planet will vanish, replaced by a fiery, molten world. So we can look to Venus's past and see our future. We know the temperature skyrocketed, and the scarred surface hints at why. In Hawaii, planetary geologist Janie Radabaugh studies the island's volcanoes. These volcanoes are a perfect model for early Venus.
What we're seeing out here are lava flows encroaching on the town of Pahoa, come all the way down from the Pu'u'o vent, which is about 15 miles away. Oh, there's hot. You can see that hot stuff. You can see hot. Quick, 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 quick. Right there. It's really beautiful.
Hawaii's volcanic lava fields look like Venus in miniature. Both produce the same kind of runny lava, building flat, shield-like volcanoes. The big difference is there are only 5 active volcanoes on Hawaii. Venus is covered in them.
One thing that really jumps out all around the planet is the number and variety of volcanoes. I mean, Venus could almost be nicknamed Volcano World.
Venus has tens of thousands of volcanoes all over the planet.
But it's not the erupting lava that turns up the heat. It's what comes out with it.
We think back to the histories of Venus. I think we must have seen a landscape very similar to this one. Have massive amounts of lava flowing out of the surface, dumping huge amounts of gases into the atmosphere, carbon dioxide, tons of gas into the atmosphere every single day. Would have been amazing to see.
Extreme temperatures weren't the only problem on Venus's surface. The thick clouds of gas kept on building up. A 155-mile deep layer of carbon dioxide piles up around the planet.
We don't think about gases as weighing anything, but they actually do.
Trillions and trillions of tons of gas pressed downwards.
There is simply so much air on Venus that on the surface it's pushing down with a huge amount of force.
Atmospheric pressure on Venus is a monster. Think about it this way. All right, car. It's time for you to be crushed, baby. If you're on Venus, you're gonna have 155 miles of atmosphere above your head. As a result, atmospheric pressure is 90 times that on Earth. So on Earth, it's about 14.6 pounds per square inch. On Venus, we're talking about 1,300 pounds per square inch. So if you're driving your car in Venus, this is what might happen.
The crusher delivers the same force as the weight of Venus's atmosphere.
This is pretty serious stuff.
The sun's heat and volcanic gases have transformed Venus into a nightmarish world. So why hasn't Earth followed the same path? Our volcanoes also spew out carbon dioxide, and we orbit around the same sun. We're not being crushed and broiled. That's because Earth formed farther away from the sun, staying cool enough to hold on to its oceans. In 1.3 billion years, Earth could hit 3,600 degrees, 4 times hotter than Venus. It will be the hottest and deadliest planet in our solar system. For Earth and its inhabitants, it's the end of the road. We could never survive the extreme temperatures or the crushing pressure. Maybe we'll escape to space. But there's one absolutely crazy way we could stay here. Move our planet further away from the sun.
We're here on top of a volcanic outcrop in Iceland with this howling gale whistling past our ears, the stench of hydrogen sulfide, of sulfurous fumes filling our nostrils. And this is about as close as we can get on Earth to high up in the Venusian atmosphere, about 35 miles above the surface of the planet Venus. The air pressure is about the same as on Earth's surface. The temperature is pretty similar as well. But the cloud droplets are full of concentrated sulfuric acid, many times more concentrated than battery acid. It's a hostile, horrible environment. But bizarrely enough, there's good reasons to think that there may be life, Venusian life, high up in the clouds there, a kind of high altitude aerial biosphere.
High above Venus, there are nutrients, solar energy, and traces of water. If life can live up there, then perhaps it might survive high up in the clouds of future Earth.
You can easily imagine these microorganisms evaporating in water particles and being transported to the upper atmosphere. Even though it turned into this toxic greenhouse planet, life could potentially still survive in that upper atmosphere.
But what about us? We couldn't survive the high temperatures or pressures at the surface, and a life in the clouds doesn't seem likely. What's our future?
If there was this life on Venus, clearly they weren't advanced enough to stop the changes in their atmosphere that led to Venus's current state. The question is, are we?
Maybe we'll leave our planet and find a new home. But there is a more outlandish solution. Stay on Earth and move it farther from the sun.
Moving the Earth is at least imaginable because, in fact, as objects exchange gravitational energy, they move in or out in the solar system. It's happened to our planet. So I could imagine engineering things where we directed large asteroids and comets close to the Earth, but not to hit it.
The gravity from these large objects would slowly alter our orbit.
Gravitational energy would be exchanged, and the Earth could slowly move out.
Each gravitational jolt would only move Earth a short distance. But do it thousands or millions of times, and we could push the Earth away from the sun. In theory, at least.
Over a billion-year period, it's possible to imagine. It would require incredible technology and incredible coordination. The technology is possible. Whether humanity as a species could ever coordinate it is something I'm a little more skeptical about.
$4.5 billion years ago, an asteroid the size of Pluto slammed into the surface of infant Mars. It melted the surface of the planet. It blew the atmosphere into space, and it boiled away the oceans. If life had gotten a foothold on the planet, that life would have been completely exterminated. But some scientists believe this extinction could have been brief, and that life could have started again from scratch. Since the 1960s, robotic probes and landers have been searching the surface of Mars for signs of life. But have they been looking in the right places? The surface of Mars is a waterless desert that's bombarded by harmful radiation. If a fourth incarnation of Martian life is alive today, many scientists think it'll have to be deep underground.
Underneath the surface of Mars, you may have all the conditions you need for life. There may be some liquid water down there, and you're also protected from the intense radiation that you find on the surface.
Scientists are split on the best underground places to search for Martian life. But if Janie Radaba were on Mars, she would head to the nearest sand dune and start digging.
Here you can see this is wet sand just below the surface. This is the perfect environment to be able to house life. Even in the very driest deserts on Earth, in between the sand dunes, in the interdunes, you can find water percolating up from springs that come up from deep under the ground, perfect for life to form and grow. And if you just keep on digging down into the bottom of the inner dune, maybe you would reach the water table. And if you reach the water table on Mars, now you have all the conditions just right for life. This is my bet. This is where I'd go, right between the dunes.
Digging for Martian life in the desert is one option. But some scientists have very different ideas, and planetary scientist Nina Lanza would need to pack a rope and a flashlight for her search.
So if I were to go to Mars to find life, I would go to a lava tube.
Lava tubes are made by ancient volcanoes, the empty leftovers from underground lava flows. Today, they form deep tunnels shielded from radiation and shut off from the harsh Martian climate.
We've never been in a lava tube on Mars, but it is absolutely possible that there's liquid water. So that's an environment where you could have some moisture, you could have a little warmth, you're protected from radiation. I think that a Martian microbe would be very happy there.
Finding life on Mars would be a monumental human accomplishment. But there is a danger. By exposing Martian life to life from Earth, could we unwittingly set off yet another extinction event?
Humans have been one of the most effective extinction mechanisms of life on Earth. The interesting question will be, will we produce a similar calamity on Mars?
If humans someday go to Mars, then we will be an invasive species. And if there is some Martian life that's hanging on in some niche, we could be their ultimate destroyers. So we have an ethical responsibility to preserve whatever life may be on Mars.
The problem isn't us, it's the bugs in and on our bodies. The average human has 10 to 20 trillion bacterial hitchhikers. If we go to Mars, we'll be taking our tiny companions along for the ride, and any one of those bugs could turn out to be a deadly competitor for Martian life. It's NASA engineer Mujige Cooper's job to keep Mars rovers bug-free. But keeping astronauts clean, that's a whole different matter.
We bake out our spacecraft hardware at 110 degrees Celsius for at least 50 hours to prevent the contamination of Mars. Unlike spacecraft, we cannot bake humans out. We will not survive those temperatures.
Unless we find a way to keep astronauts bug-free, exploring Mars with robots is our best option for keeping the Martians safe from harm. But what will happen when our robots finally find that life and we look deep into the workings of our extraterrestrial neighbors? What will the Martians turn out to be like?
Our example where DNA is the organic molecule that carries the information of life, we don't even know if that's going to be the rule book in other places. Finding any evidence whatsoever on Mars would help us better understand what else is possible.
Will the Martians be different than us, made from different materials and with a different biochemistry? Or will they seem shockingly familiar? Some scientists think that the very first Martian life may not have stayed on Mars. It may have come here.
It's not that far-fetched to think that life could have jumped from Mars or been back and forth from Mars to Earth.
If the Martians came to Earth, could they have seeded life on our planet?
Maybe the Martians aren't dead. Maybe I'm a Martian. Maybe you're a Martian.
The idea that our ancestors could be Martians is a new take on an old theory called panspermia. According to the theory, life on Earth began when a space rock filled with alien bacteria landed on the Earth, and every living thing we see today, including us, evolved from those cosmic hitchhikers. The idea of panspermia has been around for centuries, but had a resurgence when scientists determined that life on Earth may go back 4 billion years to the end of a sustained attack of asteroid showers known as the Late Heavy Bombardment.
There were a lot of objects from the outer solar system, comets and asteroids, all kinds of things, coming into the inner solar system and slamming into the planets.
Conventional wisdom suggests the objects hitting the Earth at the time were leftover debris from the formation of the solar system. But a very controversial idea suggests these space rocks were actually all pieces of Mars, thrown off in the Borealis Basin impact when a huge object blasted into Mars.
The timing links up really well for the Borealis Basin impact. If you calculate how much debris that would have thrown out into space and when it would have had to have happened, according to the Martian geologic record, it coincides with the Late Heavy Bombardment. It's possible that the debris from the Borealis Basin forming impact might have come to Earth and rained down on us and made the late heavy bombardment, seeding the Earth with bacterial spores from Mars. Now, this is just a hypothesis. We don't know this for certain. We don't have evidence. But it is physically possible for that to have happened.
Was the Earth seeded by microscopic Martians blown into space by the Borealis impact? It sounds crazy, but the science stacks up. We know that simple life is tough, able to survive in the cold vacuum of space. And the timing of the Borealis impact works out well for the rise of the first organisms on Earth. Crucially, we know that rocks ejected from Mars can make it all the way to Earth because they're still crash landing here, even today.
One of the coolest things I've done as a scientist is held a piece of Mars in my hands. Now, we never had a mission that returned a sample from Mars. We had to come about it a different way. And it turns out we have meteorites that we are 100% sure are bits of Mars. They were actually exploded out during huge collisions, and eventually they fell onto the Earth.
Four different generations of Martians, each of them facing a different planetary catastrophe. But despite enormous odds, Martians could still be alive today, buried deep under the surface of Mars, or maybe even thriving on Earth. 1,000 times more massive than the Earth, Jupiter could swallow all the other planets in the solar system twice and still have room for more. But this giant is getting smaller.
Gravity is still bringing all of the gases and liquids together. And that heats up the interior of Jupiter.
This heat rises up to Jupiter's surface and escapes into space. The planet cools and shrinks, making the gas giant a third smaller today than when it first formed. As the planet cools, the shrinking slows, from an inch a year in its infancy to just a few fractions of an inch today. And scientists calculate it could continue shrinking for 1,000 billion years. Even then, it will always be the solar system's biggest, most powerful planet. Jupiter is shrinking too slowly for us to see, but we can see the effect of this rising heat.
This is actually one of the reasons Jupiter has the spectacular weather, all of those beautiful bands of clouds.
On Earth, the sun's heat drives our weather. Switch off the sun, and our weather would stop. But Jupiter's weather would keep on going. Its weather doesn't come from the sun. It comes from deep inside the planet itself. Heat rises up through the boiling soup of gas, churning its cocktail of volatile chemicals, creating Jupiter's spectacular swirling clouds. And the whole time, the giant planet spins. At 29,000 miles an hour, Jupiter rotates faster than any other planet in our solar system.
Jupiter rotates on its axis about once every 9 hours, compared to a 24-hour day for us. So huge superheated clouds from the interior get smeared out by the rotation, and we have the beautiful cloud tops of Jupiter.
This marriage of heat and motion spawns a monster.
Jupiter's red spot is a gigantic cyclone larger than the size of the Earth and has been rotating stably with winds in excess of 250 miles per hour for over 3 centuries. Imagine a storm that lasts for 300 years.
On Earth, cyclones die when they hit land, but Jupiter has no land to stop its storms. Almost unlimited heat to fuel them, and a rapid rotation.
Jupiter is basically stoking the fires of the Great Red Spot. We're used to storms growing and then going away on Earth. But if they're spinning the right way, because Jupiter is so big and spinning so quickly, they feed into each other, and it keeps the storm alive.
Long after the other planets freeze and die, Jupiter will still be pumping out heat, driving its monster storms. Thanks to its immense size. Jupiter dominates its neighborhood for millions of miles, looming over at least 67 moons, from Ganymede, which is larger than the planet Mercury, to a rock barely a mile across.
The innermost moons are more rocky-rich, the outermost moons are more ice-rich. So, in a lot of ways, a little miniature solar system.
Jupiter is a cosmic puppet master, controlling and manipulating its moons, and perhaps making one of them home to life. March 1st, 2007, NASA's New Horizons probe flies past Io, a moon roughly the same size as our own.
Io is one of the most interesting moons in the solar system, and not just because it looks like a pizza. It's covered with volcanoes. In fact, these volcanoes, one way or another, have been continuously erupting since we've been observing Io with space probes for the past 20 years.
This small moon is the solar system's most volcanic body, with at least 400 active volcanoes. Together, they pump out 100 times more heat than volcanoes on Earth.
Io's orbit is actually slightly eccentric around Jupiter. Sometimes it's a little closer to Jupiter, sometimes a little farther away. As the gravitational field changes, Io's body, the structure of the moon itself, is twisted and pulled back and forth. And that heats through friction the interior of the moon.
That heat basically melts it, and that erupts through the surface as volcanoes.
The volcanoes on Io are really fascinating. They're ejecting vast quantities of sulfur dioxide above the surface of Io. It's split apart by the ultraviolet light from the sun into sulfur ions, oxygen ions, and those ions interact with the magnetic field of the planet Jupiter.
Jupiter's magnetic field carries chemicals and charged particles away from Io and onto its neighboring moon, Europa, making this distant, frozen world one of our best hopes of finding alien life.
When we got up close to Europa with spacecraft, we saw it was covered in cracks and ridges, which looked very much like the way ice flows look here on Earth. And it turns out that's exactly what's going on.
We know, because of seeing the flexure of the ice and the cracks in the ice on the surface of Europa, that there's probably a subsurface ocean deeper than the deepest of Earth's oceans there on that little icy moon.
Jupiter's gravity pushes and pulls Europa, creating friction, generating heat, and melting Europa from within.
Jupiter is so far away from the sun that it's natural to assume that anything around it is frozen. The fact that gravity can heat something up enough to produce liquid water is profoundly important.
All of the indications of liquid water under the surface have been indirect, the way the surface looks, the resurfacing of it. But very recently, we got direct evidence of water under the surface of Europa in the form of a geyser, a plume of water being ejected from the south pole of the moon.
November 2013, analyzing photographs from the Hubble Space Telescope, scientists spot two giant geysers spewing water 124 miles into the atmosphere above Europa's south pole. It's the best evidence yet of liquid water beneath Europa's frozen crust.
Seeing direct evidence of liquid water on Europa is terribly exciting. Finding liquid water is very important for finding biology. We don't know that wherever there's water, there's biology, but we're pretty sure that without it, it would be a lot tougher.
Jupiter, more than any other planet, has left its mark on our solar system. The largest planet with the strongest gravity. It shaped our past and influences our present. But the planet's future hangs in the balance.
The ultimate fate of Jupiter may rest on the fate of the Sun. And in 4 to 5 billion years, the Sun will expand to become a red giant, perhaps eating up the Earth in the process.
We think that the Sun's outer layers are going to expand possibly even to the orbit of Mars. The Earth is possibly going to be engulfed and completely devoured by the expanding Sun. And when that happens, of course, it's game over for Earth.
5 billion years from now, the inner rocky planets will burn up. Will Jupiter be next?
From the perspective of somebody orbiting around Jupiter, the Sun is going to turn into this angry, fiery thing. And yet, Jupiter itself is probably going to be relatively safe.
It may lose some of its atmosphere, but Jupiter's a big planet. It has plenty to spare.
Clearly, the region of the Earth will become uninhabitable. But what's also equally clear is the regions we now think of as remote, far away, frozen, will become much more attractive.
It'll be warmer, so its moons might actually warm up, and it has icy moons. Right now, they're frozen water, but with the warm sun for millions or tens of millions of years, they may actually liquefy. And Europa may become basically a gigantic water droplet, a self-contained ocean orbiting Jupiter. It's an amazing thought.
Perhaps Europa will be life's last, best refuge as the Sun dies.
As the Sun evolves, will the moons of Jupiter, could it be that they become the prime places that we either travel to, or perhaps life once again begins?
In our dying solar system, Jupiter's moons may offer a safe haven for life. But Jupiter's time in the Sun is limited.
After the Sun undergoes its dramatic red giant phase, it's going to collapse down and end its life almost with a whimper. It will become a white dwarf.
You wouldn't even be able to see the Sun from the surface of Jupiter when the Sun undergoes its final stage to become a piece of nuclear waste drifting in outer space.
Jupiter and its moons will become dark once more. Imagine Saturn without its rings, just a pale globe floating in the darkness of space. With rings, it's magical.
Undoubtedly, the one thing that captures everyone about Saturn is the rings. It's inspired fiction stories, and it's inspired everyone who's looked at it in the night sky.
When I was 4 or 5 years old, my parents bought a small department store telescope. And I remember looking down into that eyepiece and seeing this perfect jewel of a planet.
There's just nothing better than this. And you can just see the rings going around the planet just perfectly. They're just a gorgeous elliptical racetrack.
From the eyepiece of a small telescope, the rings seem quiet and serene. But up close, it's a very different picture. We know this thanks to a space probe called Cassini and over 10 years of images like these. Ice particles jostle for position like stock cars, traveling inside the rings at hundreds of thousands of miles an hour. These particles range in size from chunks of ice as big as houses to the finest powder snow.
It wasn't until we went to Saturn and stayed there with Cassini that we learned just how fiercely complex it is. You have the gravity of the planet itself and all of these moons interacting with the rings and the moons and the planet. All of these things are sculpting that entire system on scales that are both subtle and gross, and it makes this magnificent crown jewel of the solar system.
As small moons go around inside, the ring particles dance around them in response. We see areas of the rings that get raised up as a moon goes by. Moons will even switch orbits with each other. So there's a lot of dynamic stuff going on inside the rings.
Scientists believe that from time to time, Saturn's icy moons break up, adding new material to the rings. This means that the structure of the rings is constantly evolving. With Cassini, scientists can deconstruct the physics of this evolution, and it's teaching us the rules that make the whole universe tick. All the planets in our solar system evolved from the same flat disk of dust and gas 4.5 billion years ago. Astronomers see similar disks around young, distant stars, but even with our most powerful telescopes, we can't see planets forming. They're too far away. But Saturn's rings are right on our doorstep, a veritable snapshot of a mini solar system caught in the process of formation.
Looking at the rings, we're looking at the formation of planets or bodies in an arrested state of development. It's like you took the beginning stages of the formation of the planets but stopped it.
Cassini shows structures forming spontaneously inside the rings.
They don't even need to be tickled. They don't need to be disturbed into forming structures. They form them on their own.
Does this tiny moon, captured in the process of formation, show us how the Earth started its life?
You get something that just happens to form out of random processes, and that mimics what astronomers think they're seeing in protoplanetary disks surrounding other stars in the cosmos around us.
Cassini sees curious, propeller-like structures inside Saturn's broad A-ring. They're caused by ring particles washing over tiny, hidden moons. The particles collide with the moons, sending them into random, ever-changing orbits, sometimes closer to Saturn and sometimes farther away. Perhaps similar forces influence the Earth's formation around the Sun, pushing it into closer or wider orbits. Saturn's rings also help us understand why planets stop growing. A walnut-shaped moon called Pan sits near the middle of Saturn's A-ring. With so much ice around it to gobble up, Pan should be huge, but it's tiny, only 20 miles in diameter.
If you have a moon embedded in a disk of ring particles, you might naively think it just accretes ring particles until it grows into a bigger moon. But actually, we find moons create gaps in the ring around them. So Pan has created the Inky gap, Daphnis has created the Keeler gap.
Rather than pulling ring material in, Pan appears to push it away. As the moon passes the slower-moving material outside it, Pan's gravity flings the particles out into wider orbits. The faster material inside Pan's orbit is slowed as it passes the little moon, causing it to fall away towards Saturn. This natural cutoff in growth might explain why multiple planets form around stars, instead of single giant planets that eat the whole buffet. More than 60 moons orbit the planet Saturn, but one dwarfs them all. Titan is a colossus, bigger than the planet Mercury. A thick orange haze hides its surface from our telescopes, and when the Cassini mission first peered beneath Titan's orange cloak, it revealed a world weirder than we could ever have imagined.
Titan is an amazing place, and of all the things going on around Saturn, Titan might be the most exciting of all.
Titan has mountains and deserts, rivers and lakes. Only the Earth can match it for geological diversity. But here, water ice takes the place of bedrock, frozen at 300 degrees below zero. And instead of water, the rivers on Titan flow with methane.
This is a place where it actually rains liquid methane, liquid natural gas. This liquid is filling up rivers and lakes.
This makes Titan incredibly special. It's only the second world in the solar system where we know there's liquid on the surface.
And like Earth, Titan has a thick, nitrogen-rich atmosphere. But instead of the oxygen we breathe, Titan's air is spiked with carbon-rich molecules that stain it a dull orange.
It's a soup of methane and ethane and propane and acetylene. The list of organic molecules is literally hundreds long that we've detected there.
Titan's complex cocktail of atmospheric chemicals intrigues scientists, but it also puzzles them, especially methane gas, which rapidly decays in sunlight. So even 1 billion miles from the sun, Titan's thick haze should have lifted long ago. A vast source of methane must be replenishing the orange smog. Before Cassini, scientists assumed the whole of Titan was covered in massive impact craters. Perhaps cratered lakes filled with liquid methane were evaporating into the atmosphere, supplying the missing gas. At first, scientists thought that methane evaporating from these lakes generated Titan smog. But when Cassini flew by to measure the lakes again, the levels appeared to be the same. The lakes didn't look like they were evaporating at all. Scientists were stumped. Either the lakes weren't the source of atmospheric methane, or they were somehow being refilled. If Janie is right, Titan's lakes do evaporate, feeding the atmospheric smog, but they're constantly replenished by underground methane springs, replacing the lost fluid. If future missions can confirm methane-based life on Titan, it will surely be the greatest discovery in the history of science. Because this low-temperature biology must have arisen independently of life on Earth.
If we discover life, let's say, on Mars, there will always be the possibility that rocks and ice and bits of material could have been exchanged. But the chances of that happening from Earth all the way to Saturn are next to nothing.
If we find a second example of life in our solar system, especially in a place like Titan, which is so alien to the Earth, so cold and so different, that tells us something excruciatingly important, and that is that life must be everywhere in the universe.
Robotic missions offer tantalizing hints of simple life on Enceladus and Titan. But is Saturn's realm only fit for giant bacteria, or is it a place we humans could one day call home? Uranus and Neptune. Their location at the edge of our solar system makes them very difficult to study.
The ice giants Uranus and Neptune are very mysterious to us. They're very far away, so they're hard to observe with telescopes here at the Earth.
As a result, these planets have long been overlooked. The only time we've glimpsed these distant giants up close was when Voyager 2 flew past them in the 1980s. The results amazed Heidi Hammel, part of the Voyager 2 imaging team at the time of the Neptune flyby.
One of the most wondrous and frustrating things about planetary flybys is that you learn so much that you open a whole Pandora's box of questions.
One observation instantly intrigued scientists. Neptune has the fastest winds in the solar system.
Here on Earth, our winds are actually driven by different temperatures from sunshine. Neptune is so far away from the sun that it receives almost no energy from our star.
Neptune is 3 billion miles from the sun. It's really cold there. So why does it have such fast winds?
The less energy a planet receives from the sun, the quieter we expect its weather to be. But Neptune isn't tranquil at all. It's covered in massive, violent storms.
There are storms that are rivaling the size of the inner planets. That's a pretty big storm.
One of the largest ever recorded on Neptune is known as the 1989 Great Dark Spot, a single vast tempest large enough to swallow the Earth whole, riding on a jet stream with a mind-blowing wind speed of 1,500 miles per hour.
Hands down, Neptune holds the record for the fastest wind speeds in the solar system.
The fastest tornado winds on Earth are only a few hundred miles an hour, and that does devastating destruction. So it's hard to imagine what winds on Neptune would do.
A probe entering Neptune's upper atmosphere would record freezing temperatures minus 370 degrees Fahrenheit, too cold to generate the wind we see. 600 miles down, though, the probe is smashed by Neptune's relentless jet stream winds. And the deeper you go, the warmer it becomes.
Neptune has almost 3 times as much heat coming from its interior than you would expect from a ball of gas out at Neptune's distance.
The strange thing about these high-speed Neptune winds is that they're not powered by heat energy from the sun. In fact, they're powered by heat energy from Neptune's own interior.
So where does this internal heat come from?
When planets form, it's very violent, very energetic events, and the planets are actually extremely hot, and it takes billions of years for that heat to leak away. So Neptune, it turns out, probably still has a tremendous amount of that heat that is trapped inside of it, and as that bubbles up, that's what's actually heating the atmosphere and driving this tremendous weather.
So how does Neptune retain so much heat? The secret lies deep below the atmosphere.
As you go down and down and down, you would just find the pressure gets more and more intense until you are eventually essentially crushed.
That atmosphere would get thicker and thicker like a fog, until suddenly you would realize that instead of an atmosphere, you were in an ocean.
Neptune has a super dense fluid mantle made up of methane, ammonia, and water.
Really, an ice giant is not a solid ball of ice, but rather a moving ocean of swirling liquid material.
This swirling liquid traps the heat, acting like a blanket, insulating the core. This is the secret to Neptune's wild weather. And the intense interior heat and pressure in Neptune's methane-rich mantle may create another extraordinary effect.
The pressure is so intense that the methane breaks up, and methane is made of carbon and hydrogen. So if you take carbon and you compress it a lot, you could get diamond formation. And so it is entirely possible that literal diamonds are raining down in this ocean of the mantle fluid on Neptune.
From superstorms to diamond rain, Neptune is strange, dynamic, beyond expectation. But Uranus is the real mystery, the victim of a cosmic 1-2 punch with seasons unlike anything else in the solar system. If Uranus started out with a vertical orbital axis, how did it end up flipped on its side?
We know there were a lot of collisions between planets or planet-sized objects in the early solar system. It's natural to assume that Uranus probably got hit as a grazing impact from another giant object, which tipped it over on its side.
But there's a problem with this assumption.
If you hit Uranus with a single impact to knock it over to 98 degrees, And actually what you expect is that the rings left over will be orbiting in the wrong direction relative to the spin of the planet.
What event could be powerful enough to flip a planet, but gentle enough to bring everything in orbit around it along for the ride?
A single big collision is probably not what happened to Uranus, because that would have been too disruptive. It's kind of like boxing. Instead of one big knockout blow, it was the old 1-2.
One theory suggests that the newly formed Uranus is hit by a protoplanet the size of Earth. The blow is only glancing. Uranus is knocked partway towards its current tilt. Its ring system survives the impact and stays in orbit around the equator. As the second object hits, Uranus is tipped all the way, and the rings follow.
Uranus got jabbed and then knocked on its side.
Uranus, an ice giant with beautiful shimmering rings and 27 moons. And their position is a mystery. Half exist within a tightly packed orbit. It shouldn't be possible for this many moons to be in such close proximity to each other.
The environment around Uranus is very busy, and the system appears unstable, and the moons should be colliding. But yet, we see these nice, well-formed moons.
And what's even more surprising is that in 2003, Hubble Space Telescope revealed 2 new rings and 2 new moons, Cupid and Mab. Question is, where did these moons come from? A clue lies in Uranus's rings.
In addition to the very packed moon system, you also have rings around Uranus, which is also somewhat unexpected. But these 2 unexpected qualities might actually explain one another.
Anytime you see a ring system, you're seeing part of a process. There was probably a time in Earth's history when it had a ring, when our moon was being formed.
It seems that the new moons are made up of material from a previous ring system. But when scientists model Cupid's future, they discover it's dangerously close to another moon, Belinda.
In a few thousand years, 2 of the moons in particular, Cupid and Belinda, are likely to collide together as their trajectories intersect.
And this collision will create a domino effect.
When there's a moon collision, that sets up a very delicate gravitational balance, and it also creates a lot of debris. So one collision sets off a string of collisions.
We think Cupid and Belinda will destroy not only each other, but all of Uranus's inner moons. A runaway cascade of destruction grinds Uranus's moons to pebbles. All of this will happen in only a few thousand years.
The fact that we are predicting to have a collision within a few thousand years feels kind of contrived because this system has been here for billions of years. So it seems a little bit lucky that we're looking just now when we think there's going to be a collision in the near future.
Uranus and Neptune, no longer forgotten outposts of the solar system.
Suddenly, these planets are revealed to you as worlds. It's breathtaking, it's awe-inspiring, it's humbling, and it makes you proud that you're part of a species that could actually do that, to get out there and to see these places.